Hi everyone. Let's start by talking about data by describing different kinds of data. I expect most of the sections here will be somewhat review for you all, but it's good to get on the same page and have a little bit of an overview of all of the things we talk about when we talk about data analysis. I feel like data analysis is just one of those fields that, especially as it grows so fast, is full of what one might call black boxes, right? Um, all of these kinds of things that I think people like to talk about in order to confuse other people. We want to get on the same page and try to avoid as much confusion as possible in this course. So let's talk about what we're talking about when we talk about data. All right, data comes from a variety of sources. The vast majority of data that we're going to end up looking at, and particularly that we'll look at in this course, is historical and observational. This means it comes from records, examining things that happened in the past, even the very recent past, but this is sort of the stuff from the past, stuff that's recorded, stuff that's in databases. Sometimes the stuff that's in databases does indeed come from the next data source, which is a survey. Or perhaps you've put out your own surveys. I once had the fun job of asking people about their cell phones and putting out surveys. It's another way to get data, and one that we're all pretty familiar with, but that has some of its own challenges associated with it that we'll talk about later in the course. Experimental data is data that comes from some sort of controlled test or experiment, typically with test groups and a kind of base case or control group. We later in the course will talk about things that are called quasi-experiments, which are like experiments because of something that happened in nature, or natural experiments. We're also going to talk about some things that, while intended to be a sort of experiment, don't take some of the precautions necessary, like having a control that's really a control, to really get at doing the kinds of experiments they want to do, or experiments that don't pertain to the groups of people that they say they pertain to. We'll talk about these later as well. But ideally, this includes you take a random subgroup of whatever it is and subject it to a test, and a random subgroup doesn't get the test, and you have something called an experiment. Simulations are cool. Simulations are another way to get data. Well, I'm not going to go as far as I had a colleague who thought that maybe we don't need to go out in the real world and gather any real world data anymore because we could just make it all up with simulations. But simulations are great ways to sort of put our assumptions, right, into a kind of functional system and generate data that kind of represent what we think, what might happen given those assumptions. So these are fairly common, and I think becoming more common as ways of testing the implications of complex systems and how one thing informs another. Data often comes to us in a variety of forms as well. A fairly typical form is what we would call cross-sectional data. And these are observations of many subjects at a single moment in time. A single moment in time is maybe misleading. How about just saying at one, right, moment in time? So even if these are, right, everyone who came into the hospital last month, we don't know, the dates and times are less important than the fact that there's one observation about them. Here you have a look at, right, the acquisition cost for some major defense programs and their current cost estimates in 2016. A cross-section of data. Something we often find in financial management is time series data. This is kind of turning that on its head, where you take a look at one thing, like let's say expenditures on military personnel, and look at them across a wide swath of time. So you're taking observations of a single subject at multiple moments in time. Here it would be, right, US government outlays, and US government outlays across several categories at multiple moments in time. Panel data puts these together. This particular example is taking a look at military expenditures by countries over time. So there's ways that we put this together. These are kind of the examples of sort of some of the more common things you see in data, and probably a way to think about most of the data that you'll see, but certainly some data is structured and organized in different ways, even from this kind of an approach. So for example, time might be calendar time. Time might be in terms of time from an event. So you can see data in event time. Other kinds of things as well. So we'll get into some of that more sophisticated data, or at least talk about it a little bit later as you kind of take a look at what you're looking at. All right, data often comes to us in some kind of data table. And some useful things to think about in terms of our data table are what defines the cases and how many cases do we have. So here we have 3 people. You're in a class. So I'm sorry, there's going to be a fair amount of examples that come from our experiences in class. So in class, here we have 3 students, I guess, 3 people, 3 persons, if we were to be very, how our data is labeled, Joe, Tara, and Gabriel. Those are here your cases, right? The cases are defined by persons. And we have a grade, presumably on assignment 1, a grade on assignment 2, and there are 3 cases. So cases are defined by person, and there are 3 cases in this example. We can take this same data and look at it a different way. Once we do this, right, we actually have person class are the cases, right? So each case is a person and a class. So we have 2 variables here are defining our cases. So Joe in class 1, Joe in class 2, Tara class 1, Tara class 2, Gabriel class 1, Gabriel class 2. And now we have 6 cases. So we can take that same data and look at it a different way and define it a little differently. Here, right, we've taken that same data and looked at it differently, and our cases are now classes. So we have class 1 and class 2 as our cases, and we only have 2 cases, right? And so we've taken the data, summarized it differently, and looked at it in a different kind of data table, which gives us different kinds of information. Finally, the fact that we've talked about that, the data about the data in general is what we call metadata. So all of this kinds of information, these kinds of information we've been talking about, plus a few other things, all kind of are the things about the data. So where did your data come from? What kind of data it is? What time period it's about, if it's a cross-sectional data or event time data, who the cases are, as well as things like the number of cases, what defines a case, what kinds of data it is. All of this makes up the metadata, the data behind the data, or the data about the data. All right. A couple more thoughts about data that you have. One thing is that we often want to know something about an entire group. So why some of this metadata and who the sample is really important. We say we want to know something about a population, the entire group you want to draw conclusions about. We usually only observe data about a sample, which is the subgroup of the population you have data about. We're going to talk a lot about inference. Inference is about taking information from the sample and projecting it onto what we want to know about the population. We're going to talk about when the samples are good samples, when the samples are bad samples, what makes good and bad samples. But for now, understand that these are 2 important concepts for how we think about using data to draw conclusions. Another thing that's important is that numbers aren't always numbers. Numbers can mean a whole bunch of different stuff. There are the numbers that are the kind of numbers you're used to thinking about. These are what we might call cardinal numbers, numbers that are counting, right? And these can be both discrete, so 1, 2, 3, or continuous, 1.12, 1.337, 1.98, et cetera, et cetera. So these can be a variety of kind of numbers, but these are just normal numbers. So you think I'm crazy now because I'm talking about numbers as numbers. Yes, sometimes numbers are numbers. Sometimes numbers aren't exactly numbers. And that's what we get to next. Ordinal data are numbers that represent ordering. So these are still kind of numbers, right? The numbers are relevant to what they mean. So first, second, third, those are still numbers. But was first place necessarily as far ahead of second place as second place is ahead of third place? Not necessarily. Similarly, worst, fair, best, right? On a scale of 1 to 3, they're in order, worst, fair, best, 1, 2, 3, but is 1 to 2 necessarily the same as 2 to 3? Not necessarily. We see these a lot in what we'll call Likert scales that float around in surveys all the time, right? Where you rate things on a scale of 1 to 5 or a scale of 1 to 7 or any of those kinds of scales. They're in order. 1 to 7 is in order, but it's not necessarily that the space from 0 to 1 to 1 to 2 to 2 to 3 is the same. And that means these don't exactly work the same way as either discrete or continuous cardinal data does. And there's going to be some separate rules for how we're going to deal with our ordinal data. Finally, nominal numbers are numbers that are assigned that are neither, right? So these are sort of meaningless numbers. What do you think? Can you take the average of the numbers on the players' jerseys on the soccer team to get some sort of useful information? No. Can I add up their numbers? No. There's nothing about those numbers besides that they give a name or they're nominal. They're numbers used to confuse us. They're numbers used as names. So sometimes we have categories 1 through 3, right? Bus, like we categorize transportation as taking the bus or driving your car or walking. There's no order to those. They're just numbers that are used as names. And sometimes there's some stuff that's a little confusing. Is it ordinal? Is it nominal? Most of the time we can end up treating a lot of ordinal data as fairly similar to nominal data anyway. But remember, nominal data presents in some ways a challenge because sometimes people will start to use them as numbers when they really aren't.